IPv6 and the routing protocols. To understand that, we got 5 routers and we got multiple networks here. Each router has got a loopback interface and a physical interface, at least one physical interface each. And if you take a router 3, it has got 2 physical interface, but one is Ethernet, another one is serial. The reason why I have taken different type of interfaces, it's not going to make any difference. IPv6 configuration on WAN interface as well as LAN interface is same. So I would like to show you that. Even if I have frame relay, configuration is same, but the frame relay map when you write, there will be a slight difference. Those things are not needed because frame relay is out of picture now, but you can still watch my old videos to understand IPv6 over frame relay. Now, here we are not having any frame relay, we just got one WAN interface, one LAN interface, and many networks. We'll start with static route. Before that, let me do initial configuration on all this router. Initially, I have router 1 with 2 interface, one logical and one physical. For that, let me give IP address, enable config t host name, that is not needed, interface loopback 0, IP address 1111:1/128. You can see some people writing IPv6 unicast routing command, IPv6 unicast routing command in the global configuration mode. That is good only when you do routing. Here I'm just doing initial configuration. When I do routing, when I write static route, if I am, I'll not be able to ping the remote network, then I need routing. So in order to enable the routing feature, I type IPv6 unicast routing. By default in IPv6, routers are not going to do routing without you saying IPv6 unicast routing. Now what happens really when I say IPv6 unicast routing? When I say that, it joins a multicast group called FF02::2. It joins a multicast group called FF02::2, which is a routed mode. Alright, so those things I'm going to show you. Before that, let me give the basic configuration. Fast Ethernet 00. No shared IP address is 2000:12:/64, or let's see, 32 EUI. No, I cannot say EUI 64 if I say 32. I'll say 64 itself. 64 and then EUI 64, which means first 64 bits I have already determined what it's supposed to be. It should be this network, and the remaining 64, the interface ID is taken from the MAC address, added FFFE in the middle, and it turns it as extended unique identifier, which is unique because of MAC address in it. Those things we already saw in CCNA level. Alright, now this is what I need here. I'll say end write to memory. So just to give IP address, what I'm coming to say is, just to give IP address, you need not to say IPv6 unicast routing. IPv6 unicast routing command is not really going to enable IPv6 on a router. IPv6 is enabled automatically. By default it is there. Only routing is not enabled. See, when I paste, one minute, let me copy. Select all, Control C. Something is wrong. You know what is wrong? I have typed IP. It is IPv6 space address. Pasting once again. It is done. Okay, it's done. Let us check show IPv6 interface brief. We got loopback interface and link local address is automatically given, and then similarly here on the physical interface we got an address. Now what I'll do is, if it is given by the router itself like this, when we do troubleshooting or when we try pinging from remote, we need to come and copy this address. Instead, what I'll give manually an address, the complete 128-bit address, interface fast Ethernet 0/0. First of all, you need to cancel the old address if you don't want. In IPv4, if you want to have a new IP address, you write new IP address, it overwrites the old IP address. In IPv6, you need to cancel the one and then put the other one. Why? IPv6 interfaces support routers on router interface supports multiple IPv6 address on same interface. You can have multi-stack. I'm going to give an IP address, IPv6 address 2000:1/64 IPv6 space address. Alright, now let's verify show IPv6 interface brief. Yep, the address has got changed. Now I also want to change the link local address manually. I want to give a link local address. Is that possible? Yes, it is possible. Let me show you that. Interface fast Ethernet 0/0 IPv6 address FE80. We know that all link local address will start with FE80 :1/64. Sorry, link local. By giving this command, we can statically assign a link local address. When we give link local address statically, we can really troubleshoot, or we can understand what's going on when they form neighbor. I can give the same link local address even to the loopback interface. That won't conflict. Why? The scope of link local address is only on that link. Loopback is one link, fast Ethernet is another link, so it won't conflict. So when I say show IPv6 interface brief, I can see the link local address for loopback interface and the link local address on the fast Ethernet is same. And we can see here both the interface have got same link local address. Same link local address I showed you on the loopback interface. Now you are seeing on the fast Ethernet, they don't conflict. And this is user defined IP address, the complete IP address. Similarly, I'm going to do it for the rest of the routers. Let me go to router 5. Router 5 also has got only two interface, so I'll say 5.5.5:5 and then link local address, I'll say IPv6 address FE80:5 link local. This is for router 5. And on interface fast Ethernet 0/0, it goes like this: 45. And there is no EUI64. I want to give manually the interface ID. Done. I also want to give the link local address manual. Done. That's it. I'll copy and paste it on router 5. Yes, router 5 is ready to go now. So quickly let me finish the other routers. Router 2 has got two interfaces, fast Ethernet 00 and fast Ethernet 01. So 01 I'll make here 32 and 2 here, and this one will be 12, 2, link local will be 2, and then the loopback address will be loopback interface address will be 2. Router 2 ready to go. Just two more routers. Now this is for router 3. On router 3 loopback interface address will be 3. This I would like to change it as serial 1/0, which will be 34. 3. This will be 32.3. That's it. Select all, copy, I'll paste it down to router 3. It is done. One last router. So this router has got 4 on it as a name. So I'll say 4. And serial 1/0 has got 34.4. Fast Ethernet 00 will have 45. 4. That's it. Select all, copy, paste it on router 4. Now assigning of IP address is over. Let us just try pinging the adjacent device and check whether we are able to ping. Before that, let me type you show IPv6 route. You see, it shows the directly connected 34 and 45. So I should ping 2000 colon 34 colon 3. It pings. This is router 3. It pings router 3 without any problem. Pings router 3. Likewise, I need to ping 2000 colon 45 colon 5. It pings. Now, will I be able to ping 555::5? No. Why? Because there is no route to the destination. Show IPv6 route. I don't have the route. Now let us finish static route. How to write static route? IPv6 route, anything that starts with 555::/16. I'm just matching with the first hectate. Hectate. If this match happens, send the traffic to whom? 2000::45::5, which is router 5. Done. So simple. Now let us verify. Show IPv6 interface brief. Show IPv6 route static. It says that if I need to go to 5 network, I need to go to router 5. So I'm going to ping 555::5, repeat 100 times. It pings. So this is how we write static route. Now let's go to router 5 and ping router 4's loopback. Ping 4444::4. Not possible. Ping 2000::34::4. Not possible. So I want to write a default route because it's a stub router, because it's the edge. There is no multiple exit. Only one exit for router 5, that is via fast Ethernet 0/0. I want to write a default route. How to write a default route on IPv6? IPv6 route 0:0:0. 0 ::0. No, not like that. Not like this. Just ::/0. Send the traffic to 2000::45::4. That's it. This is what default route. Any network, you go to router 4. Now if I ping router 4's loopback interface, I'm able to ping. If I ping the router 4 serial interface, I'm able to ping. If router 4 has route to reach 3333, then that also I can ping from here. Right now if I ping 333, it won't go beyond router 4 because router 4 don't know where is 333. It will go to router 4 and router 4 don't know, so you won't get the response. So it is not saying I'm not having route. It says I have route. I sent to R4. R4 is not responding. Let's trace route and see. Trace route 3333::3. See, it goes. It will go to router 4. The first hop itself is not responding. That's why I'm getting like this. Okay, so actually it goes to router 4. If router 4 knows how to reach 333, let me go to router 4 and write a static route. I'm going to say IP route, if you want to go to 333, send it to 34.3. Now packet will go to router 3, but router 3 don't know how to come back. What should I do? You can write a static route for the reverse path. Going to router 3 and writing a static route to reach back router 5. So I'll say IPv6 route 5555/16. You can go to 2000:34:4. Now if you see from router 5, when I ping, the ping will not happen unless I source it with. If I ping like this, it won't ping. Why? Packet goes to router 3, but router 3 don't know how to reply back to this address 2000:45, because I wrote static route only for 5555. So if I say source with 5555:5, then the ping will happen. I'm pinging 3, sourcing with 5, it will go to 4, show IPv6 route, static, it knows the route to reach 3 and 555, it will send to router 3 by using this address. When it goes to router 3 will receive show IPv6 route static. It needs to respond back to 5. It will deliver the packet to. Okay, I'll tell you why this ping is not happening. This is where the routing starts. The reason why ping is not happening is when you see here show IPv6 interface serial 1/0, this has just joined a multicast group whose scope is only on the link, not routed group. But when I say IPv6 unicast routing, now it has joined the new multicast group called ::2. This makes the routing capability for IPv6 enabled. So it was not actually our static route problem. It sounds like, some static route problem, but you see it pings now. So that command IPv6 unicast routing is very powerful. I didn't give it on R5 or R4. Why? R5 and R4, they just hand over to the next gateway. It is R4 the one takes from left and give it to right, and take from right and give it to left. Neither source nor destination is in R4. So R4 is the one which is doing real routing here. That's the reason I enable that command IPv6 unicast routing in R4. See, before I give the command, it was not having FF02::2. But after I give the command IPv6 unicast routing, you can see it has joined a new multicast group. This makes routing to happen. Hope you understood the static route and default route. Let's get into RIP. I'm going to remove all the static routes that I have given here. Remove it. Done. Show IPv6 route static, nothing. Similarly, I'll go and remove on R5. R5 I gave a default route. Show IPv6 route static, not there. Router 3. Right. So I removed it. Now, when you enable a routing protocol, your router must join the multicast group before you enable any routing protocol. It must join FF02::2, which I showed you under the interface. See, I'm trying to enable RIP on R1. See what happens. I have not joined the multicast group, but I'm trying to enable RIP. How to enable RIP? Go under loopback or physical interface and say IPv6 RIP. Give any name. I'll give name as CCNP. Enable. See, it shows an error. IPv6 routing is not enabled. So what I need to do? I need to say IPv6 unicast routing. After giving this command, if I give the RIP command, it will accept. It accepts. Now you need to use the same name. It can be any name. You need to use the same name all over this router. Interface fast Ethernet 0/0 enabled. RIP is enabled. You need not to do anything on the global configuration mode. I enabled RIP under the interface. See this? Show IPv6 protocol. You see RIP has been enabled. RIP is enabled. The name is CCNP and it is running on this two interface. Is there any other verification? Yes, we do have another verification. So this is one. We got two interface running RIP. Show run. See, we didn't do anything on the global configuration mode. We configured on the interface. We configured RIP on the interface, under the interface, but globally you can see that RIP is also enabled globally. See, IPv6 RIP route. We didn't give this globally. It is enabled globally when you enable it on an interface. So I'm going to enable RIP on the other router 2. Interface range command. I can use range command also. Fast Ethernet 0/0 -1. For the fast Ethernet, I can use range. For serial, you cannot use it. I'm going to say IPv6 RIP. Give any name. This name and the previous router name need not to match. If it match, also nothing wrong. Name is locally significant to the router. I'm going to say here router 2 _ RIP. Sorry, enable. Now again, it's the same complaint. You did not enable IPv6 route. So let's enable IPv6 route. IPv6 unicast. Alright, it is enabled. Now going back to the range command and enabling. RIP is enabled now. I would like to enable on loopback also. Now let's verify. Show IPv6 protocol. We see IPv6 RIP R2 _ RIP is enabled and running on this 3 interface. Likewise, I'm going to enable on router 3, but I think it's not necessary. You had one sample how to enable RIP. It's the same way you're going to enable RIP on all the other routers. Let's see the routing table now. Show IPv6 route RIP. You can see that the loopback interface of R1 is reachable from R2 now. Ping 1111::1 with my source 2222::2. If this ping happens, Both the way the learning is done. You can also check it from router 1. Show IPv6 route RIP. So through RIP here I learned two network. One is 2000:32 and 2222:2. So if you want to ping 2000:32:2, which is behind 2, with my source of loopback 0, I'm able to ping. So here we understood how to enable RIP. Now let me cancel RIP. How to cancel RIP? No IPv6 router RIP CCNP. I globally cancelled. Let's verify. Show IPv6 protocol. Look at this. I enabled it under each interface, but to cancel, where do? I did it on the global. Let's check whether the interface has got the commands. Show running interface loopback 0. Even under interface loopback 0, I don't have the command. Removed automatically. I'll show you for fast Ethernet 0/0. Even here I don't have the RIP configuration. Automatically removed when I remove from global. Similarly on R2, I'll say no router, no IPv6 router RIP R2_RIP. Show IPv6 protocol, no RIP. Show IPv6 route RIP, no route. So will the ping happen now? No. So we have finished two things: subnet mask, static route, default route, that is one, RIP. Next is the wonderful EIGRP. Let's see how to enable EIGRP for IPv6. If you want to have EIGRP, you need to have any of the interface with an IPv4 address that will be used as a router ID, or you can manually give a router ID. See, like this. I'll go to router 1, interface loopback 0, I'll give IP address 1.1.1.1, just some IP address. This is going to be taken as a router ID for EIGRP IPv6 version. Must. Either you can give an address on the loopback interface, it will take automatically, or you can give manually straight away under the IPv6 EIGRP. I'll do it on the next router. Now here I want EIGRP to pick the address dynamically from the loopback interface as a router ID. So I given this address. IPv6 router EIGRP. Here we need to give a name. The name I want to give is R1 EIGRP. I'm sorry, I need to give autonomous system only. Okay, autonomous system. I'll say 10. And in here I need to say one command, no shutdown. That's all. Straight, you need to go under interface now, enable EIGRP, IPv6 EIGRP 10. That's it. Interface loopback 0, IPv6 EIGRP 10. EIGRP is enabled in this router. What's the proof? Show IPv6 EIGRP interface. See, EIGRP is running on these two interfaces. Show IPv6 protocol. EIGRP is running on this router. EIGRP 10 is running on this router. It's an IPv6 version of EIGRP. Autonomous system number is 10. The other metrics, everything is same like your IPv4. See the router ID? I didn't give it, is picked automatically. Administrative distance is same for internal and external. Maximum hop count support is same. Variance is same. Maximum path is same. Interface that it supports. Now let us go and enable EIGRP on router 2. What's the first command? IPv6 router EIGRP 10. I'm going to give manually the router ID. EIGRP router ID 2.2.2.2. This is the command to give router ID manually. And then I'm going to say no shutdown. I cannot say network command, nothing like that. There is no command called network available here in the list. You have neighbor, you don't have network. So everything has to be done under interface. Interface loopback 0. IPv6 EIGRP 10. Interface fast Ethernet 0/1. IPv6 EIGRP 10. Interface fast Ethernet 0/0. IPv6 EIGRP 10. Now I am expecting a neighbor. Look at this. Neighbor is formed. Link local address is used to form neighbor by all routing protocols. What is the use of link local address? It's for neighbor discovery. So this is the reason why I give link local address manually on every router. Now you can understand that R1 has got neighborship with this router. Show IPv6 EIGRP neighbor. I see that the link local address of R1, that is what neighbor with this router. Now if I ping 1111::1 with a source address of 2222::2, I was able to ping. Show IPv6 route EIGRP. I am able to see the route learned through dual algorithm. Let me also show it on R1. Show IPv6 EIGRP route EIGRP to routes. So if I ping this 32::2, it should ping, which is behind R2. So we saw now how to enable EIGRP in IPv6. Let us do OSPF now. I'm going to remove EIGRP, no router, no IPv6 router. There is also one more command. No IPv6 unicast routing. If I disable this, all routing protocol will be disabled. Shortcut. You want to check? See, show IPv6 protocol, no protocols. Show IPv6 EIGRP interface, no interface, no EIGRP. So let us put back IPv6 unicast routing command. This is the best method of cancelling a routing protocol. No IPv6 unicast routing. EIGRP is removed. IPv6 unicast routing, I'm putting it back. Let me show you. Show IPv6 protocol. No EIGRP. You need not to go and say no IPv6 router EIGRP 10. Not necessary. Now two more protocols left. Let us quickly enable OSPF and then BGP. OSPF. For OSPF, if you have a router ID to be picked from a loopback address, you need not to go in the global configuration mode. You can straight away go to the interfaces and say IPv6 OSPF process ID area ID. Because I have already a loopback interface with IPv4 address, that will be picked as the router ID. Interface fast Ethernet 0/0, enable OSPF. So similarly, I'm going to enable OSPF on all these 5 routers. So I'm saying enable config T, and then what? IPv6 unicast routing, interface loopback 0. Let me give manually, give the IP address, 32-bit IP address, so that it can be used as router ID by this OSPF. This is just an ID for processing that IPv6 OSPF. This is not going to be routed. IPv6 OSPF 1 area 0. Interface fast Ethernet 0/0. IPv6 OSPF 1 area 0. Interface fast Ethernet 0/1. IPv6 OSPF 1 area 0. See how easy it is. Copy all. I'm pasting this on router 2. Now router 2 is done. See, it has already formed neighbor. See the router ID. It is the layer. It is the IPv4 address. Now if I ping, the ping will definitely happen. The ping happens. I'm going to paste it on router 3 now. Serial 1/0, and the router ID is see, this also has formed neighbors. So quick, very fast. IPv6 has got fast convergence capability because of neighbor discovery using link local address. So let me do it for router 4 now. One last router I'm going to do manually. IPv6 unicast routing. Interface loopback 0. IP address is 5.5.5.5. This will be used as the router ID. If you want to give manually, go to the global configuration mode, go under IPv6 OSPF process ID, and then give the router ID manually. IPv6 OSPF 1 area 0. Interface fast Ethernet 0/0. It's the same command. Done. Now if you ask me to ping from here 1111::1 with my source of loopback 0, I will be very happily pinging. I'm sure this will ping. That's it. Now we also learned how to enable OSPF in IPv6. Now one last thing I'm going to show you with BGP. BGP, I'm going to do really IBGP. EBGP is very simple, you know. IBGP is also simple. I'm going to form IBGP between R1 and R5. I'm going to first of all disable OSPF under loopback interfaces and advertise that loopback interface in BGP. So I'll say interface loopback 0. I'll cancel that OSPF. Likewise on R1 also I'll cancel that OSPF. Now if you ping from R5, this ping will not happen. The ping that happened sometime before, This will not happen because I removed those routes from OSPF. OSPF is no more distributing these routes. I'm going to distribute through BGP. For that I want to form IBGP neighbor between R5 and R1. So how to do that? It's very interesting. Slight difference. I'll say router BGP 10 address family IPv6 unicast neighbor router 1's address 2000:12:1 remote autonomous system I'm sorry, just activate command, no remote autonomous system. But for that, first of all, I need to, wait a minute, before I get into address family, let me do it from the beginning. See, I said router BGP 10, and here itself you say neighbor 2000:12:1 remote AS. I'll give same because IBGP we are doing. And then get inside the IPv6 address family and then activate this member. Activate this member under IPv6 address family. And if you want to advertise this 555 network, say network 55 mask 120, yeah, 128. See how simple it is. I'll go to router 1 and do the same. Router BGP 10. My neighbor is 2000:45:5. Remote AS is 10. Address family IPv6 unicast. The same neighbor need to be activated for IPv6. And then I'll say network 1111:1/128. Look at this, neighbor is already established. Nice. Now you're going to see through BGP, I'm going to ping from R1 to R5's loopback. R1's loopback to R5. Show IPv6 route BGP. Show IPv6 route BGP. Show IPv6. Try again. Show IPv6 BGP. Show BGP IPv6 unicast summary. See, it has formed a neighbor with R5, but it has not learned any prefix so far. We need to check why. Before that, I want to check what this advertises. This is advertising perfect 111 local next stop. So give some time. Or clear the neighbor, clear IPv6. Okay, anyway, it has got resetted. Summary command again. Still, I'm not seeing any network learned. What about router 5? Let us go and check on router 5. Router 5. Do you learn anything from router 1? Show IPv6 route BGP. Wow, this has learned. This has learned the route that was advertised by R1. So let us check why R5's network is not seen there. Show BGP IPv6 unicast. It says I am learning this from router 1, But I'm not advertising anything. Why? Let's check why. Show IPv6 interface brief. My loopback interface has got this. Did I advertise that? Show IP protocol. I'm running BGP, but where is the network? Show run router section router. It says, you see, I put extra 5. I put extra 5, that's my mistake. So I'll go to this location, I'll change this. I'm going to change this. That's it. We are done. Now I tell you, definitely this ping is going to happen now. From R1, this time I see there is one prefix learned from R5. Show IPv6 route BGP. Cool. 5555::5 with the source of my loopback 0 pings. It will happen. You know the reason why this ping is not happening? It's very basic. None of the middle router knows about 555 and 111. So we need to enable BGP on all routers. So anyway, you learned it, the routes are coming. If this packet needs to go to router 5, it has to go to router 2, and in the router 2 it will check the routing table for 5555. There is no route. That's why. Hope you understood how to enable IPv6 on all by using all routing protocols. We stop here. If you have any question, you can ask.